everybody, welcome back. Thank you for joining me for week 6 of Graph Adventures with Wine. So working with the wine data set that I found on Kaggle, about 8 weeks ago now. So it's cool. So let's get cracking. What's the plan today? So as you recall, we spent a couple of weeks trying to sort out pulling years from the wine. Finally we've done it. We're there. We've managed to extract the year from the wine title that we had, and we've also managed to create like a generic wine group, which is basically the wine title but without the year. So that's great. So what I want to do now is I just want to do a quick recap on a couple of things that I've done since the last time we had this session. I just want to quickly explain what I've done. Then the focus of today is going to be, what exactly does designation do? So if you recall, when we started this journey and we were looking through the data set, and for those of you who are new and just joining, don't worry, if you go to the address at the bottom of the page here, you will be able to follow everything that's happened. So every week I will write up what we did, what did we discover, what challenges we had. So we keep a detailed report of all of that. So if you're new, don't panic, just go to that address there. But what we did, so we loaded a load of data and we had this designation and we weren't too sure what it was, but we included it anyway. So I thought today, let's go have a look at that and see what's going on there, because I have a feeling it might not be so useful. I had a quick peek and I was a bit, not too sure what's going on there. But that aside, we're going to have a look at that. And then what I want to do as well is we've got another node there called variety. And if you recall, it had some grape names in there. But it was a little bit weird because we had different spellings for grapes, and also we had things like actual grape varieties that are the same but have a different name, like Shiraz and Syrah, and we haven't decided what we're going to do with that. So I thought, let's also, if we've got a bit of time as well today, let's go have a look at variety, and do we need to do some data cleanup on that, and what exciting stuff does that tell us? So that's the plan. So again, as I said, if you want to follow along, you can. So you've got all the information in that link there that will take you to my GitHub repo. That's a shorter address than the actual address of the repo. So go there, have a look. You'll be able to follow along. If you're not quite set up, don't worry. Next week, you'll be up to speed and be able to follow through. Anyway, let's get cracking. So just nipping over to the repo here, and as you can see, this is my write-up. So write-up for week 6, and there's a couple of bits I added that I just wanted to quickly chat to you about. So after we've done the year, so let's have a quick look at the data model. So here is our data model now for our wine. So here is our wine, and obviously, as you may recall, we've got the taster on there, we've got the winery that wine came from, there's that mysterious designation node that we're going to explore today, and then what we've been working on is trying to extract the year and the wine group from wine, and we've created those two nodes, and then we've got variety. So that's another node hopefully we're going to look at today. And if you may recall, that some of the questions that we asked at the end of last week, when we've managed to extract that year and wine group title, was 2 4 forward. So which year had the most wine? So basically, which year was the most popular of the wine? Which wine group had the most year nodes? So basically, this is trying to say, for example, if you've got, I don't know, Portuguese Red 2014, Portuguese Red 2015, Portuguese Red 2016, we just want to find which of the wine groups, i.e. Portuguese wine, has the most number of years. So that'd be 2014, 2015, 2016. So that's that question. And last but not least, which winery produces the most wine for a given year? So the idea was we wanted to look at a winery, and for a given year, how many different wines did they produce based on the data. Obviously, this is not going to be an accurate reflection of all wine produced for a given year. But we wanted to have a look at that because that might be quite interesting to see. So I just want to quickly go through something in particular. So okay, we've got here, this is the wines per year, and I've put in a little chart which I've bound together in Excel, and I just mention here as well that you can export a CSV direct out of Neo4j browser. So I'll point the button when we go back into browser, but I've got a little circle on the picture as well that you can see. And the other interesting one that I did, so if you recall, we went through this and we discovered that when we went to find out which wine groups had the most number of years, there were some duplicates in our data. So we had, it's probably a little bit small here, so maybe if we click on the image, see a bit bigger. So you can see here, for example, this wine here had a couple of years, and then what we discovered when we queried was, here's a lovely image representation, is that we had duplicate wine titles. So our assumption that we made that every single wine in the CSV that we imported was unique was false, unfortunately. So one change that I did not cover in the session last week that I did earlier today was I wanted to get rid of the duplication. So I'm just going to quickly talk through what I did. So I had a quick look, and we had 471 duplications of the wine title. That's okay. So I was feeling brave, and I just knocked together a query, and I'm just going to quickly talk through what happens in this query, because something like this might be useful. So I've done this match wine group in one group wine from year. And then here, this with the wine group, with the year, I'm collecting the wine. So what this effectively does is we'll have one of these, so per wine group per year, we're going to collect all of the wine. So this is going to collect all of the duplicates. So they've got the same wine group in the same year into our collection called wines. And I'm doing this where size of wines is greater than 1. So basically, where the size of that collection has got more than one wine node in there, so that's going to get rid of everything that's not duplicate, and we're just going to keep the duplicates, the triplicates, and so forth. So that's great. So I'm doing that. Now here is the little fudgy bit that I do, and what I'm basically saying is, so we know that the collections are greater than 1 that we've got, and what we're saying is with wines 1, so bearing in mind that these arrays start from 0, so 0 is the one we want to keep, and then we want to delete the next element. So that's what I'm doing for 1. So with wines, so that'll be the second node in that collection. So we're detach, delete, W. So we're going to detach and delete that second item. And that's what I've done to just quickly get rid of the duplicates that we had there. And I'm doing a little bit cheaty here as well, because there were 2 of the ones that came back were actually triplicates. So, and again, I've manually iterated this, but you can use things like APOC iterate is a good example of this. So what I've just done is I just ran it another time, and then it's just going to get rid of that. So you think about if you've got triplicates and you do 2 passes. So the first pass, so you're going to have 3 items in your array. So we're deleting the second item in that array, and then we're now left, when we rerun that query, we're going to be left with an array of 2 items. So when we rerun it again, it's going to delete the second item, and then we're left with an array of 1. So that's what's going on. So that's one thing I've done. So I've changed the data. So we now have gotten rid of all of the duplicate wine titles that we had. This only applies to wines that've got a wine group and a year. So you may remember that there's some wines that don't have a year. We may have some duplicates in that. I'm going to go away and deal with that later, but so you just see what's going on there. So that's one thing I've changed that we didn't talk about in the video. So I've done that, and then you'll see that I've removed duplicates from there, and then obviously we've got that query there. So that was just a quick update on what's going on there. Right, let's get going with designation, our mystery node designation. So let's go and just see what we've got in there. So you may remember, again, when we were loading the data in, was it week 1 or week 2? I can't remember which one it was. We had some things with designation, with country, with province, where sometimes there was no item, that was a null field in the CSV. So we created a node designation label for the nodes. So I'm just ignore that. So let's have a look at the kinds of designations that we have. So let's do match d designation, return d.name, order by d.name. So let's have a look at the kind of things that come back. And this is quite interesting because we get some really weird things coming in. So this 19 Phantom Lim Belmont Vineyard, 50 Munja name, social secret. There are some quite strange things. And if we wanted to see the numbers, so how many wines have we got per designation, so that might be an interesting information, we can extend this out slightly. So let's do this as designation wine, and then I'm just going to do a count of this. So what I will do is just put in a with D, collect W as wines, and then I'm going to return d.name. Let's do size wines as S, order, and I'm going to do this by the designations that got the most number of wines. Order by S descending. Let's see what happens. Okay, so unsurprisingly, no designation has the most, so that's fine. That's the one we created for the null fields. And then we see some interesting things. So we've got things like reserve, estate, reserve spelled in a different way, estate, grown, brut, etc., etc., etc. So that's interesting, and we see a split around these. And one thing I wanted to do as well is have a look at what does the wine title look like when we do this. So I'm going to, I don't want to do these crazy big ones because, you know, that's going to use a lot. So let's pick the ones where it's not so high. So if we say where wine designation is less than 60, and let's have a look at the wine title. So we've got designation where size wines is less than 60, and what we want to do here, so we've done that, and then what we're going to do is wines, and let's do this, and we're going to just limit it by a few. So we're not going to do a crazy number of these. So let's do title. Oh no, let's collect it. What we can do is let's collect it back up again. So nah, let's just do one.title limits 10. So let's have a quick look at what's going on. So I will admit I did have a cheeky little look earlier, and something that I noticed when I was digging around was you'll notice that the designation seems to be, and this is my theory, so I'm going to need to have a dig around and have a look at the Kaggle source where I got this from, if there's a bit more information about how they got the data. But you can see that the designation seems to be like some kind of rule that's been run that takes the things that come after the year. So you can see here, so it's the Svolka Bianco comes after the year, Vidagos comes after the year, Reserve Late Harvest comes after the year. An interesting thing here as well that caught my attention is that something's going on where it doesn't catch this red, or for example here the Viognier or the Riesling. So that's quite interesting that's going on there, and I think that we're definitely going to have to dig around. But I very quickly came to the conclusion that I don't think designation is something they've got out, but I think it's data that they've processed from the title. So I'll give you one example of something that caught my eye, which was with the designation where it had organic, and you see lots of different things. So let me give you an example of that. So where lower d.name, and I'm doing lower because you'll see why in a second. So lower name contains organic. So I want to just get designations that contain the word organic, and what you will see, and I think we can safely, because there's not so many of those, so I'm going to do this, collect title as wines, and then we're just going to I don't even think we need this, to be honest with you, because they're not a huge number. So if I do return the wines, the name and wines, then what you will see is so this variety made of organic wine. So you can see this again coming after the year. Again, said made with organic grapes, loads of different groups. So you can see what's going on here. So it's not like it's telling us it's an organic wine. Well, obviously it is, but my point here being is that it looks like that this has been extracted out of the title. So I am very much minded for now to just leave it. So this may well be useful information at some point, but I think I'm going to park it for now. So one thing actually we can do whilst we're here is, can we solve the thing about variety? Because let's have a quick look. So this I haven't looked at yet, but let's have a quick look to see whether variety has been extracted. Whilst we're here, we just extend the query. So let's do v variety, and we're going to, I just want to keep v as well, and I'm going to do v.name and wines, and let's see what comes back. And this is probably where we discover that actually it has been, the variety has also been extracted from there. So that's fine, that's okay. The variety is probably a little bit more useful. Oh no, look. So we've got sparkling blend, but here it just says sparkling. Okay, so I'm curious as to whether or not this has been generated, or has this come from somewhere else. Just spotted something. Looks like the years problem has not left us alone, because if you notice here we've got Mendocino country, whereas here we've just got Mendocino. And if you remember how we extracted the year, these would be treated as two different wine groups, whereas obviously us looking at it now, we should treat these as the same wine group, and this is the wine from two different years. So I'm going to quickly take a note of that, because I think we're going to revisit that when we have a look at the provinces and that kind of thing, so that we can come and fix that. So let's just quickly take a note of that. Actually, I'm going to just copy this so that I can remember what was going on, what we were talking about. Cool. Okay, so we'll have extracted the year for both of those, but we won't have the wine. But there's lots of really cool things we can do to do that, so that's not a problem at all. So let's have a quick peek at what is going on. So yeah, there's another one. So this is white, and it's white blend. So I wonder if there was some kind of rule that was put in there if it ends with. Oh no! Look, here we go. Here's another one. Made of organic grapes, but this is a Tempranillo blend. So, okay, I suspect what's happened is that maybe this has come from somewhere else. Okay, so that's cool. So let's then move on to having a look at variety. So, just going to take a copy of the queries. Actually, I'll take a copy of them later. Right, okay, so let's have a look at varieties then. So, same idea. V variety, and we're going to return the names. Have a look. And I don't know if we've got an example quite close up, but we've got a bunch of interesting things going on here. So we have things like Alicante and Alicante Bruschette, and I don't know if those two are different or not. We'll have a look in a bit. But the interesting thing here is, would we say these two are the same? So we can go away and have a look, and again there's little tricks that we can do to join those together. But we've got this, and then there was another example where, there you go, again, the hyphen's always interesting, but we can never think about how we treat that, and I suspect what we may do is perhaps tokenize these, because it could well be of interest for us to know, like, have you got like some kind of a Chardonnay blend or a Shiraz blend or something like that. That could well be interesting to us, Cabernet Sauvignon, that kind of thing. Do we want to split these out and start joining wines together based on grapes? So even though there's a grape mix, but maybe if you really like, I don't know, a Shiraz, then you might be interested in Shiraz blends as well. So I think that we'll probably go away and tokenize these and have a look. But I just wanted to show you one that's interesting, like this one, Aragonés and Aragonés. So things like this, I'm going to sort of put my put my head above the parapet there and assume that these are both the same. They've just used different spellings. And we've got a few of these as well. And what we're probably going to want to do is to some way sort of join them together and say, well, actually these two are the same. And we've got a few of these. So this one again, Assyrtiko, again spelt in a different way. I'm pretty sure these are the same. So there are things we can do to make that a bit easier. So there you go, just scrolling through so you get an idea of what's going on. So what we can do, and I've done this previously, so if you've come across my BBC Good Food recipe stuff, one of the things that I was looking at was dealing with duplicates. So we had duplicate ingredients, so what do you do with flaked almond flakes and that kind of thing. And there's a few of the tips and tricks from there that we can borrow. So a lot of that stuff I use the APOC text stuff. So let's dive into that and have a look, because I think what we can do is have a play with, not going to find it in here. We can have a play with the this is what I wanted, with the text functions. So there's a few text functions that we might find useful. So let's just bring those up as soon as I can find them and just search for text. Probably a quicker way. There we go, text functions. So there's a bunch of text functions that we can probably find helpful. So the text similarity functions. So what I want to do is have a look at Levenstein similarity. I've used Sorensen dissimilarity before, so we can have a look at that as well to see what happens. We may well use, there's a function here called APOC text clean, and that's quite useful because it's going to get rid of like accents on words, and it's going to get rid of any characters and things. So we can have a look at the difference that's going to make when we apply it, as a precursor to some of the other functions. And we've got double metaphone as well, which I use for the ingredients, but I don't think it's going to work so well with the wines. Because what double metaphone, and we've got like phonics and things like that, is what they do is they try to look at a word and then say what would be the pronunciation for that word, and then it replaces it with some letters. So we'll have a look when we run it. And then you kind of go, well, is these set of letters that you've reduced my word to match this set of letters with my word, and if they match, then we go, yeah, they sound the same, therefore they could well be the same word. So the idea being, if you spell Sammy Sammi and Sammy, the idea is they both sound the same, like Sammy. And then you go, well, actually they both sound the same, so maybe it's the same thing and somebody's misspelt it or something like that. However, given that we have got grapes from all over the world, so we've got like French grapes, we've got Italian grapes, we've got German grapes, and they're all going to be pronounced in a different way, because I think double metaphone is very much going to be from an English perspective, how we'd say things, so it's probably not going to work so well. So we can have a go and have a look at what gets output with that one. But I thought I'd mention those because that works quite. Oh, you've got some examples here. So that works quite nicely if you're trying to find lots of different tools to compare two words together. So you're saying, well, I'm going to check what the, how well the words match, then I'm going to use some kind of phonetic comparison, and I'm going to do other things as well. I'm going to see like what do they neighbour to, are they similar as well. So that could be useful. Probably not going to be useful in this example now. So let's first of all have a go with Levenshtein similarity. So we need to pass in 2 parameters. So let's do that now. So what I'm going to do is I'm going to get variety, and what I'm going to do is we're going to bring back 2. So this is going to be a Cartesian product, but that's okay, because what we want to do is we want to get 2 variety. We're going to get variety because we're comparing variety against variety. And what I'm going to say is I want to make sure that I'm never comparing against myself. So a little trick we can do is if we look on the internal ID, because this is nice and fast, and we say where the internal ID, so where V1 internal ID is lower than V2 internal ID. So we can do that, and then let's just return the Sorensen distance and see what comes back. So return APOC. Actually, return the title, so v1.name, v2.name, and then we want to do apoc.text. No, we're not doing sorry, so we're doing Levenshtein. Let's have. I'm just going to copy this, as it's not auto popping up for me. Right, and then we're going to say v1.name, v2.name, and we're just going to limit these. We don't do all of them, so let's do limit 10 so we can see what's going on. Oh, we wanted the other Levenshtein, but okay, we can see what's going on. So you can see there's a massive difference between these two. Let's have a look on and let's go for it. Let's do it where the distance is a bit shorter. So I'm just going to quickly add in a width, v1, v2, and I'm just going to borrow this as distance. Let's call it as D, where D is less than 3. Go on, hopefully we should get some stuff that comes back less than 3. And we're going to bring back D as well to see what the difference was. So let's see what comes back. Ah, there we go. So we've got Merlot and Melon, Gourmet and Gamza. So it's useful for some things like Insula and Insula, and Petit Verdot and Petit Verdot. I assume I'm going to put my neck on the line here and assume they're the same. And Rosado and Rosato. So these are all sort of like just pronunciations. So okay, so we probably agree that these and this are, and this one here are probably going to be the same. But obviously Merlot and Melon massively different. So probably not going to be the function that we're going to use. But the one I wanted to use was Levenshtein similarity. So that gives us a value between 0 and 1. Because the problem the challenge that I have with Levenshtein distance is I find it a little bit. It's great if what you're comparing are like all your words are the same sort of length. But the challenge that I have with it is that you're getting a number, and to me the number is almost, it feels a bit meaningless, because what are you comparing it to? What does 11 mean? I mean, if you're comparing 2 sentences that are like 140 characters each, and you've got Levenshtein difference of 11, that's probably good. It means the 2 sentences are very similar. Whereas 11 for this, that's no good at all. Quite different. So it's a little bit funny about what does that mean. So this is why I much prefer something which is going to give you some kind of a ratio, so you can work with that. And that's what Levenshtein similarity does. It's going to give us a ratio between 0 and 1. So let's do that. So again, we can let's do this same idea. Let's see what comes back. So there we go. So you can kind of see things like everything here like not similar at all. So let's tweak this slightly, and let's say where D is greater than 80%. Let's see what happens when we do 80%. I'm living life on the edge here. Let's bring back 20 results. Okay, so we're doing this, and again, probably worth mentioning as well. And even though this is a relatively simple function, this applies as soon as we start going down this route where we're picking a threshold for saying what's right and what's not right. Is always be aware of the underfitting and overfitting problem. And what overfitting is that you two points. So if you underfit, then you've not picked an optimal threshold or optimal values for your parameters, which means you could probably be missing a bunch of stuff that would, past example would be missing a load of things that could map together and that be classed as similar. Whereas overfitting is where you've introduced so many parameters or you've tweaked the threshold so much that it works perfectly for a sample bit of data that you've put forward, but you're never going to meet that criteria when you then run it on the rest of your data. So just a couple of things to bear in mind. So the only reason why I'm flagging it is I'm having a quick look here and my very scientific eye sitting here going, well actually things like Pinot Blanc and Pinot Bianco, oh, that's a tough one. This is fluke. I'm going to argue this is fluke because I don't know. Because I would argue that obviously Blanc is white and Bianco is white and Italian. So this is French white and this is Italian white. Practice our languages. So I'd argue that's probably the same grape. And I kind of guess if we dig into it, like we do have like common letters of B-A-N-C, and the difference here is we've got an I and here we've got an L and here we've got an I and we've got an O at the end. Okay, that one's probably okay. Whereas we've got here Tempriano Blend and Tempriano Blanco, and those two obviously not the same. So we're probably going to have a little think about how we can handle that. But a very quick unscientific eyeball at and here got Rosato Rosando. But a very unscientific quick look seems to suggest that around 8.33, something like that, catches them. So let's just see how many come back at 80%. So I'm going to get rid of the limit. And let's order them by D, descending. And let's see what happens. So it might be quite slow. Oh, that was quite fast actually. Impressive. So, okay, so I don't think we're going to argue about these ones. This is just like an L's missing. Here we've got Tinto. Fine, we're not going to argue with that. So far so good. I think we would probably argue these are all the same, so that's fine. The Syrah and the Shiraz is an interesting one, and I think it's probably because we've got the I bet you it's because it's the SHAR. So the letters, again, that's a bit fluky that the letters kind of map in the same way, and maybe that's what we need to fix the Shiraz Syrah question. But okay, that's cool, that's there. So we're having a look at that. Muscatel. Again, I don't think anyone's going to argue too loudly about these. It's just that where it gets interesting is this one here, this Blanc and Blend. And again, it's probably worth mentioning as well. Maybe we can solve this perfectly, maybe we can't. And it's just bearing in mind that maybe we're just going to have to accept that some of these are wrong, and that's okay. Maybe we can do something where we do some kind of exception rules where we spot if it's Blanc and Blend's always going on, then we can put some rules in there and say, hey, ignore that. The fact that we've only got 32 with a threshold of 80% is not too bad. Of course, there may be some more going on. And we're going to try that APOC text clean in a second, see what happens. I'm dead intrigued by this one. Grau Burgunga and Blau Burgunga. So we'll have to have a look at that to see. I suspect they're probably different, but the fact is that there's only 2 letters out of the lot, which is why Levenstein Similarity go, yeah, quite similar. So you've got the same idea, we see what's going on. An interesting thing as well, and this is why it can be a bit hard, is obviously you're going to get this weighting. So yeah, Sauvignon Malbec, Sauvignon Barbera, and again what will happen is because there's going to be similar letters in there, and the challenge that we have is obviously the longer the word is, or the longer the you know our string is that we're comparing, then that's going to get a favourable score. Whereas if you've got a relatively short word, so let's pick that's funny, Vranac is sparrow in Serbian. Vranac, I don't know what that is. Maybe that's a spelling thing again, we'll have to have a look. But what you'll spot is here where you've just got a one letter difference, you know, it gets this lower score compared to like these two words, like, you know, us looking at it, like the word's different. So we'll have to look at that, and things we can do is we can like tokenize the words. So maybe that's something we can have a play around with next time in the future, is we can concatenate those and play around with the words to see if we can bring in lots of different facts into the mix to help us figure out how we can deduplicate that data and join things together. So, okay, so we see what's happening here, and then again, like border cell white blend, border cell red blend, those are completely different. So there's little tricks we can do, but we're getting an idea of what's going on. So let's have a go at the, we've got this, where are we hiding it? It was text clean, so let's see if that makes a difference to what we've brought back. So what I'm going to do is I am going to do I'm just going to split it out just to make it a little bit cleaner, so we don't have a massive line. So with V1, V2, yeah, let's do it like this. Let's do it like this. APOC text clean v1 dot name as name1, APOC text clean v2 dot name as name2, and then that's what we're going to bring into the line similarity, so name1, and then we'll have a go at Sorensen distance as well in a second for good measure. 2 as d2, and we probably want to have a look at what happens. So I'm going to bring name1 and name2 along for the ride as well. Let's do v1, name, v1, 2. I'm going to do these next like this. 1, name 2, d ordered by d descending. So let's see what happens. So same idea, so you've got these ones. Let's see if this changes match. So this is going to, ooh. Oopsie daisy, that's fine, let's get rid of this. So let's see. So this is also going to remove spaces as well. This is going to be removing hyphens. This is going to be removing all sorts. Oh my goodness, we can definitely see that it's made a difference. So you can see removing that space has made a difference. And you remember before we had all of the Tinta del Toro right at the top. So straight away the Petit Verdon. So that's made a difference. So I'll have to have a quick look to remind myself what exactly happens when you do the Levenstein similarity, whether that, I assume it will lowercase things, but it's not going to remove spaces and hyphens and that kind of thing. An interesting thing as well is you can see how certain things have, okay, so not a massive change to the list. Not a huge change. But what is interesting is by removing the hyphen, because and this kind of makes sense, is you've now made this slightly shorter because you've removed two characters that both of them had, so they both had the hyphen and a space. So you've removed the two characters, which means you've got fewer common characters when you're doing the comparison, which is why you can see that's dropped. Okay, so it's not made a life-changing difference, but did we have this? Aha, we did not have this one before. Okay, so we can see that it's that. We can see that Levenstein similarity is not doing anything about the accents on the letters, so it's helped us find these new ones. So we discovered an extra. So how many records did we stream last time? 32. Okay, so we've got an extra winner that we like for that. Okay, so that's what's going on. So let's try now the Levenstein. So. Not Levenstein, sorry, Sorensen dice similarity. So same idea again. So I think let me bring it up. with language. The only problem is how would we even begin to try and guess? And we've got all of these various similarity things. Let's have a go with this one, see what happens. And then again, you can of course just go and have a go with the different ones to see what happens. So we're just experimenting a little bit now to see what happens. So let's just quickly see. Just trying to remember what it returns. So I can't remember if we need to go towards 0 or towards 1. Let's run it and see what happens. What's the worst that can happen? So what we're going to do is we're just going to limit what comes back, and then we can adjust accordingly. Aha, sorry, I've just noticed there's a question that's appeared on the chat, so my apologies, sorry to have missed your question. So what I'm doing, I am actually running browser. So you've got a number of ways. So you've got Neo4j browser, which allows you to sort of query like I'm doing now with the data, and it's a web-based browser. So you've got a number of ways of how you can be working with this. So what I'm doing at the moment is I've got a database running locally, and then I just do localhost :7474, and that brings up the browser. So that's how I'm interacting with the database. What you can do as well, so I'm using a local database, but if you want to join in and just have a play with the database, and in fact you can do it with the wine data as well, you can spin up a sandbox, and that you don't need to install anything or download anything. So I'll just stick a link in. I'll stick a link in now into the chat, so you can go in and have a play with the sandbox, and there you see a button for browser. So let me just do that now and you can have a go. So for those of you watching the video later, it's neo4j.com/sandbox. So we got the link for that. Right, so, oh dear, what did I do wrong here? I have April, what did I miss here? I'm not sure. Let me see what's going on here. Text. Well, this is cryptic. Where ID with v1, v2, a pop. No, we still have done something that it's complaining about. Well, this is exciting. I'm not sure why it's not happy. Just in case I've misspelt something, I'm just going to copy the entire thing from here and paste it in. No, okay, right. Oh, I know I did it. I forgot to do this. I know, I've commented out. So when you use with, you always have to give it an alias when you're bringing something back. So I forgot to put an alias in. That is why it is complaining. So now with my alias, let's see what comes back with source and dissimilarity. Oh, okay, right. So I think we want to. This is the one where we want to go but do we want low numbers? All right, let's do a D above 1. Let's see what comes back, and then we can do it, but let's see what happens another way around. Can't quite remember what comes back with this. Okay, so it probably is. So if we do less than 0.5. Oh no, it's going to complain because I've put too many characters in. Right. Oh, okay, yep. So high numbers are good. So the only problem here is, as you can see, is that we're not getting the same nice bit of matching as we were getting with the other one. So again, let's try what we did before, where we had the where we use the clean to see if that makes a difference. I suspect it's not. I think we're probably going to be using Levenstein Similarity for this. So I'm just going to borrow this, and we're just going to put in, change this one to Sorensen. And we're going to go above. Does anything above 1? Let's see what happens. So this might not help so much, but that's okay. Let's just try it out and see what happens. And this is when I discover actually, oh no, we only had about 5 last time, so that's fine. Yeah, so that's not so helpful, unfortunately, but that's okay. We had a try. It's probably going to be Levenstein distance that we're going to use. So I talked a little bit about the phonics filtering as well that there was there. So we have this, and I use this really well for when I tokenize the ingredients and then matching them together. So I'm just going to quickly show you. So I don't think it's going to work so well with these ones, but let's just see what happens. So these are functions rather than procedures. So we have to do the call APOC and then yield something. So let's have a go at this. And I think we need to put it into an array, if I remember correctly. Let's see what happens. Okay, so let's reuse this again, and I'm going to get rid of this. Let's do this. So call epoch.text.double metaphone. I think we need to just trying to remember if I need to put this in an array or not. Oh yep, I remember now. You put this into an array, don't you? So if we do v1.text, v1.name even, v2.name, yield value, and then we're going to do with v2 v1, and let's go this value naught, that's name 1 value. So effectively what double metaphone is doing is it's taking that taking our wine varieties, and it's going to convert it into a set of characters. So you'll see in a second, which kind of represent the sounds that they make. So let's do value 2 as name 2, and then let's return them and see what happens. So I'm just going to limit this, limit 10, so you can see what happens, and then we can do an equal. So let me just quickly do this so you can see what's going on, and then we can have a look at what did I do. Oh, yep. So what? I made the fatal mistake of I need to. Oh no, I did give it a string. So yield value. I'm just going to have a look at. I'm just gonna cheat and go to medium and have a look at what I did last time, because I'm obviously not remembering this correctly. So let me go have a look at what I did last time. There we go. If in doubt, reuse what you last did. Okay, so I did as yield value, collect value, and okay, no, fine. That is good. Okay. So and then let's do val naught and val 1, limit 10. Right, so you can see what's going on there. So effectively it takes a word and it tries to sort of pick representations for what the sound is. So what I can do is, if we say where val 0 is equal to val 1, so this is where we're saying, so where the sounds from the first variety is the same to the name of the second variety, now we're going to return it back and see what happens. And I think we're going to get some really interesting results. Cool. Okay. So some of them are not too bad, but got 10. Like you have some really crazy fermentino. This is when I go off and Google this and discover that actually they are the same grape. So you know what? Let's do this. Let's see what happens. Grape, wine grape. So fermentino. This is when we discover it's. Okay. Okay. And what was the other one that we had? We had ferment. Okay. Oh, it's a Hungarian grape. Okay, I think it's fairly safe to say they are not the same grape, but you know, let's just the great Google circle. Let's see what happens if we do those together. No, they are. I think it's fairly safe. Oh, I don't know. I'm going to have to go off and poke around. I think they're not the same. Oh, did you say also known as? Oh, it is. Okay. Okay, maybe there is something in this. I think I'm going to have to. I think certainly, well, all of us, we can go and have a dig about. So that's interesting. So I'm on a mission now. I need to see if these two are the same, because it could well be that actually, if you think about the translations, or you know where the words come from, that they, you know, they'll have a, we may not know where they originally came from, but perhaps they will have similar names. So let's do wine grape. Let's see if there's anything between these two. Got Fiano and I suspect those two are different. So this is probably an example of where we do a combination of things. So we do a combination of we're going to do a combination of things like, let's look at the similarity of the two words. Maybe we're going to use phonics as well to help us out a little bit. So we can do that. Well, that's fun actually. So this starts to open a whole set of exciting possibilities, because you sort of think, say, obviously Hungary is well known for their dessert wines, their sweet wines and that kind of thing. So maybe, you know, maybe you like sweet wines, but maybe it's a particular grape, and maybe you'll like that grape if it's being used in like a traditional white wine or something like that. So that's quite exciting. Okay, you know what? Let's drop the filter. I'm gonna limit this to. Oh, let's go crazy. Let's do it 30. I'm gonna quick look what else comes back. So this will probably do a bit of scoping, but again, it doesn't have to be 100% correct. I mean, I'm pretty sure Pinot, well, I don't know, Pinot Noir and Pinot Nero, I don't know if they're different, but that's interesting. So what else has come back? Sangiovese and Sauvignon. I suspect they're different, but I'll have to go away and have a look. Moscato and Muscat, I believe, are the same. Okay, so there may well be something here, although I'm pretty certain those two are quite different. Okay, something to look at. So maybe what we can do as well, we might put some kind of a rule where the words have to have a similar number of characters. So maybe there's a few rules we can put in place to try and deal with that. Okay, so that's interesting. So we've had a look at double phonics, and that probably worked a bit better than I was expecting. So that's cool. So a bit more research to be doing there. So that's the wine varieties. So let's see. I want to just do a quick count as to how many. Now this potentially is going to be quite a slow query, so I'm going to run it with the expectation that I might kill it because it's going to take a long time. So bearing in mind, I think we've got something like, oh my goodness, like, actually, how many varieties do we have? I think we've got something like a few thousand. So we're going to do Cartesian comparison against all of those, and double metaphone is, you know, obviously does a lot of work. So let's just quickly see how many do we actually have. So let's do count v1. Let's just see how many actually come back. And whilst that's running, let's just quickly see how many varieties we've got. Oh, 123. Oh, okay. And how many varieties do we have? We have got 708. Oh, okay, that's all right. Wait, I should perhaps check that before we started. So, okay, so we've got 108 varieties. When we did the Levenstein Similarity, we returned about, I think it was 33, and I think there's a bit of an overlap with that, along with the double metaphone. So we've got 123. So that's interesting. So without tokenizing what we've got, we are looking at probably shaving off 130. So we can bring that 107 down to about 570 different varieties. And if we then tokenize the grapes as well, we're probably going to end up with maybe 100. So that'll be interesting for matching wines and doing wine recommendations. So that's interesting. Okay, so I'm just going to that's right, I'll take a note of what we've done, and then I'll write all of this up into the repository so you can go away and have a look at that. So that's cool. So let's just do something very quickly, because you know how you get the sort of wine blend. So what I'm going to do is I want to bring back some of the varieties where we've got hyphen, because the hyphen usually suggests that we've got like the grape blends. So let's just do that. So the variety where v.name contains hyphen. Oh, let's live life dangerously. Let's return everything. Turn v.name order by v.name. Let's see what comes back. Oh, only 163. That's not too crazy. Because I'm wondering, are we going to get a situation where you get, like, let's pick, like, you got Cabernet, Merlot, and do we have like a Merlot Cabernet? Displaying the first 50 rows. I'm just going to quickly make a change in my settings so that I display more than that. Max rows, I want 200. Okay, right, let's rerun that again. So to rerun a query, you have this nice little handy circle at the top, which I'm going to run, and then it's going to display. Oh no, give me all the 50 records, please. I want all the records, not just the 50. There we go. I had to rerun it in a new window. That's okay. So we said we've got this Cabernet Merlot. Do we have a Merlot Cabernet? Or Cabernet Shiraz Cabernet. Let's do that one. Let's do Shiraz Cabernet. There we go. So what we're probably going to need to do, and I think we'll probably do that in the next session, I think, is what we're going to want to do is we're going to tokenize all of these. So where this is like one node, this is one record, I'm going to split this out into 3 nodes to come off, and the idea being that when I compare these two, they're both going to have a connection to Syrah, they're both going to have a connection to Cabernet, and then obviously they don't map these two. That's okay, that's cool. And then we can then deal with that, what happens if we've got different orderings. So definitely see that's going to Syrah Grenache, and I think they're probably like Grenache Syrah. Let's have a quick look. There we go. Alright, look, the 2 different Syrahs. Alright, so I reckon that's what we're going to do. So I think we will have a go at that next time, or do we even want to have a go now? I mean, I'm kind of tempted. I want to see what happens. Oh, you know what? Let's do it. Let's do it. Let's quickly do it so we can see how many components come out of variety, and then we can have a look at how we can map out the things like Syrah and Shiraz, and how we can sort of think about joining them later. So let's do that. So if I bring back the data model. Let's bring back the data model and have a look. So remind us of that. So call db.schema. And okay, so you remember we've got wine, we've got variety. So what I'm going to do is I'm going to create a new node type, and I'm going to call it variety component for want of a better name. So we've got a variety component that's going to come off there. So if you think here variety is Cabernet Sauvignon, then we're going to have one variety node called Cabernet and one variety node called Sauvignon. And then we can start joining them together. So let's have a look. I did this in this blog post as well, where I split things out. So I'm probably going to steal bits that I've done in the past. So how did I tokenize? So tokenize my bits and pieces. This is me cleaning stuff up. We're not worrying about that today. And okay, so what we did with that. So what I'm going to do is I'm going to split with hyphen, and I'm going to split with space, because some of those have got space, some of those have got hyphen. So let's see what happens. I'm going to steal this bit of code and rewrite it. I'm going to first just create an index. Variety component. I'm just going to call it variety name, because I'm going to end up misspelling component. I know what I'm like. I'm just call it name. Just create that. Okay, right. Let's do this. So I'm going to do match. Oh, I did multiple splits. So let's do match. Ooh, let's see what. This is the one I want. Okay, so we're going to match variety. I'm going to make everything lowercase, and then what we can do afterwards is we can go through, once we've tokenized everything, we can do that APOC clean. I'm going to clean all of the names as well, so that we can deal with the accents, all of that stuff, because that helped improve our accuracy of stuff. So let's have a go at that. So with v.name, that's names for each n in names. We're going to merge v and variety, and then say, yeah, that is component of I. Now, when I last did this, you could only do split on a single character. Since then, there's been a new version, there's been a new version of Cypher, and you know what? Now's a good time to have a go and use it. So you can now do arrays of strings, so array of characters to split with. So let me just have a look at that. I just need to see where can I find it. Bear with me one moment. String functions, there we go, that's promising, isn't it? Split, right, so okay, it's not in the docs, so this makes it a little bit exciting, because I thought it had been done. So let's, you know what, let's live life dangerously. Let's have a quick I'm just going to grab a copy of this. I'm not going to run it just yet. I am going to do a little test run to see if we can figure out how the split functionality work. If we can't figure out, that's fine. We just run split twice. You know, it's not a deal breaker. So let's just have a go. So let's do with my fake array text of, let's say, blah hyphen blah space blah. Oh no, I'm gonna do it like this, don't I? I don't want to put an array just yet. As test, and let's do return split test. And so if I just do one character, which is the space, then we should get blah blah. There we go. Right, cool. Now, can I do an array? Oh, I'd be so excited if this works. And just close the array. No. Expected string, but was list. Oh, I'm so sorry about that. I thought that had been introduced, but it hadn't. Okay, let's have a quick look in APOC. Does APOC have a big split? If it does, then happy days. That's what we're going to do. Let's have a look. Otherwise, we're just going to have to do multiple. We're just going to have to do multiple splits. So we can do it with the regex. Oh, okay. Let's have a go at that. Let's do that. You know, that might be a nice way to fix it, and then that's problem solved. Okay, so apoc.text.split. We've got our test, and let's give it a regex. And I'm not the world's greatest regexer, I'm sorry. Do we do something like this? Hang on, is it something like that? Space, or do we need to put in brackets? We'll test it. If anyone on there is a regex expert, by all means, let me know. Oh, hey, okay, brilliant, right. APOC to the rescue. Right, so let's bring back my text that I had. And we're going to use APOC split. So apoc.text.split. We're going to lower the name. Let's bring in the wonderful regex pattern that does its magic. Or hyphen as name. Okay, so basically let me just quickly talk you through what's happening here. We're matching all the varieties. We're then applying a split to all of them, and I'm using a regex pattern, so we're splitting either by space or by hyphen. We're going to do names, and then what I'm going to do, because that's going to create like an array, so we're saying is for each thing in that array, what we want to do is we want to merge. So merge basically says if it doesn't exist, go off and create it. If it does exist, then just match it and find it. So we're going to merge that variety name there, and then we're going to create a relationship between our variety. Oh no, in this VN. VN is a component of V. So basically what we're going to then do is we're then attaching that variety name. So for example, if we've got Cabernet Shiraz, we're going to attach Cabernet to Cabernet Shiraz and Shiraz to Cabernet Shiraz. So that's what's going to happen there, and it's going to run across everything. So let's do that and let's see what happens. Famous last words. Oh, that was quick. So it's 558 nodes. Okay, let's see what those nodes look like. Name. Order by v.name. Okay, cool. So remember we had 708 varieties before. So just by tokenizing, so you can see we've probably got a lot of things going on. Oh, and there you go, that's probably going to go. We'll talk about stop words, I think, another time. So just by doing that, we've just gotten rid, like we've reduced down to the 538. So if I bring up Shiraz as the variety name, and then we can see all of the varieties that have Shiraz. So let's do that, and I've a little bit of fun with that. So let's do match VN variety name Shiraz, and this component of the variety, and let's return everything. Oh, what have I done? Have I misspelt something? I probably have. Maybe I will pick a wine that I can spell. Let's see. Okay. Right. Oh no, I've got this. I've got my relationship the wrong way round. The arrow should be over here. Okay. Hey, look at that. Look at all of these blends, or obviously Shiraz, I'm just saying. Look at all of those. So you can see that, and what we can do to make it look a little bit neater is I can just return the name. So let's do v.name. We're going to return those, order by v.name. So this coming back is exactly the same as the bubbles there, but you can see that. Look at that. All of these things with Shiraz. So where this becomes really interesting, if we're trying to think about we're building like some kind of a recommendations engine. So we're trying to say what wine should we recommend based on grapes that you like. This becomes quite interesting because we're not just going to say just Shiraz, but maybe you're going to be interested in all the blends. And then you go away and you try the blends. And an interesting thing as well is it, you know, if you drink a Cabernet Sauvignon, or sorry, Cabernet Shiraz, do you like it because it's the Cabernet? Do you like it because it's Shiraz? Do you like it because it's both, combination of two? So you can start to get some really interesting things going on here. And by tokenizing those, the grapes, we can start to do some really interesting things. So whilst we're here, whilst we've gone to the effort of splitting out all of those the components out of variety, let's have another look at some of the similarity stuff that we're doing earlier, because I think we'll probably have a little bit of fun now with this. So I'm just going to quickly scroll back to one of the queries where we had, I'm going to leave double meta, no, we'll come back to double metaphone. Let's go back to oh, that's so long-winded. Let's keep it for now. Let's keep it for now. And we're going to do the clean. So we'll run it in query now, and then we'll go off and do the clean afterwards. So we'll go and update all of the names. So I'll show you how to do that. We'll have to be a bit careful because this is where we might start running into little problems. It's all good now. Right. Let's do this. So we're just going to change this. So this is now going to be variety name because we want the components. Name, and everything else stays the same. So let's see what happens. Oh, that error in bracket strikes again. Hey, okay. Oh, look at this. Look, we've got some accents going on here. Oh, look at this. And look, the really thing as well, this is basically all saying that these are a complete match. So, oh wow. Oh my goodness, that is quite, just look at the ones that is coming back as one. That's quite a few. So you can see straight away we can start collapsing these. And what we can do is, because we've cleaned it up at this level, we can then pass the changes back down again. So this is cool. Oh wow, okay, look, this has made a big difference, hasn't it? I still got this one, so we're going to have to figure out how we're going to deal with this one. Or we just accept that sometimes it might be a little bit wrong. Or maybe we need to put in some kind of a threshold saying that if you're over, I don't know, 7 characters, then you need to have a higher threshold to say that you match. So we'll have a go at that in a second, because now I'm really curious. So let's have a go with that in a second. But look at this. Look at all the This is very cool, isn't it? We didn't put a limit on this, did we? No, we just said order by descending. So go on, let's live life dangerously. I'm just going to do it down to 0.7. So we're dropping the threshold a bit. Let's see what comes back, and then we're going to do that thing where we're going to change it slightly with the thing. So the only thing to bear in mind is when we change it by the length, we're probably going to lose this one, which is the same. But this is the life of when you're working with the data. Is you have to accept that maybe some mistakes might happen. So we either say, do we want a high tolerance and we just accept that we get this one wrong, or do we want a low tolerance and we miss these ones, which are like this, and this. We lose all of these ones as well. Let's have a quick look, and then we drop it down to 0.7 because I am really curious now. And then we'll go back and try the meta. We'll try the double metaphone as well. So have I got this one running? There we go. Right. So let's see what appears at the bottom of the list. Oh, look at this. We are. Yeah, we're going to have a really interesting one here because these ones are now starting to map, and I suspect they're not the same, and these ones are starting to map. So at some point we're going to have to draw the line, and maybe what we can do is cheat a little bit as well, where what we say we perhaps match the first name. So we'll cross that bridge when we come to it. But we can, okay, so we can see we're probably going to keep it at 0.8, and maybe we're going to have to add other rules in as well to try and map that. So let's quickly do the clean and all of these names. So the clean, as you recall, is going to get rid of all of these accents. We don't have any other characters, so it's going to, everything else is alphanumeric or letters. It's just that it's going to get rid of the accents. So do we want to do that because we might break something? Oh, let's do this. Let's do a quick. What we're going to do is quick test. Let's do match v1 variety name, v2 variety name, and let's say where. Again, same idea. Little trick to make sure that we're not comparing against ourselves. So where v1 ID v1 is greater than less than. It does not matter. ID. Oops. ID v2, and so this is what we're going to do, is we're now going to do the APOC clean text. So we just want to bring back where those two match. So let's do this. We're going to say where apoc.text.clean v1.name is equal to apoc.text.clean v2.name. So let's see how big the problem is. Return v1.name, v2.name, and let's see, I should leave it for now, this is fine. Let's see how big the problem may or may not be. Oh, 6 nodes. Okay, this is not the end of the world. Because bearing in mind we've done a merge, so these should be unique things. So what I'm going to do is I am probably going to get rid of half of these. So let's do that. And then we can carry on. So what I'm going to do is, oh, this is going to be so nasty, but it's fine. So with v2, so I'm just getting all of the nodes here. I am now going to get rid of them. So detach, delete v2. Goodbye v2, it's been good knowing you. I'm going to grab a copy of that so I remember what I did. That gets rid of 6 nodes. So what we can do now is we're now going to run that clean, knowing that we're not going to do any crazy thing or introduce new duplicates. So let's do that. So let's do v variety name, and let's do. Oh, have I just? No, I've done. Okay, right. I'm going to pause for now because I just realised I've done something that had a little bit greater significance than it should have done. So I'm going to rerun that create function. I'm going to explain to you why what I did was a little bit hasty. Right, let's just so I'm just rerunning this. So it's not going to create anything new because we're using merge. So if it already exists, it's just going to it's not going to break anything. So it's just going to add 6 nodes. There we go. Right. So let me explain to you what I've done and why it was bad. So I thought all I could do is delete these v2 names, But if you remember when we added these nodes, they're coming off of wine. So what I need to do is I need to move the connection between these nodes over to the wine for these nodes, then I can delete it. So what I did was very, very hasty. So let's sort that out. So what we're going to do is we're going to come back to that previous query. And then what we're going to say is with v2, so what we're going to do is first we need to attach them to, we need to find out the wine for v1. So let's do this. Actually, this is probably... Okay, let's do it like this. So let's say with... let's do it like this. So we want to get the wine for this one. So let's say... so not the... Sorry, not the wine, the variety. So let's say... is component of... variety. So this is what we need to keep, because what we're going to do is we want to get this variety, and we're going to get rid of this relationship, we're going to be getting rid of this one, so we need to connect this onto this. So let's do this. So with let's do this. So we're going to do v1 merge v1 is component of var. Okay, so that's we're connecting it, and now what we can do is with v2, now we can get rid of it, and I'll give you an example of what's going on so you can see what's happening. So with v2, detach, delete v2. Right, I'm going to grab a copy. Oh no, I did not mean to do that. Control A and copy. Let's just copy that so I know what I did. And let's run that. So again, so should create. There we go. Deleted 10 relationships, created 10 relationships. That. So we've rehooked them in. So let me give you an example of what's going on there. So if I now search for this, you'll discover it has two. It's actually, is it going to show that? It's not. Just take it on faith that what's happened. I've detached the variety that these ones connected to, and then now connect onto these ones. Okay, so we've done that. Now we can do the cleanup. So let's do that. So let's match. v.variety name. Oops. v.variety name. Set v.name. So setting, we're setting the property, but we're setting the properties itself. But when we've cleaned it, so we're going to do apoc.text.clean v.name, and that's going to get rid of all of those characters. So let's do that. That will be pretty quick. Oh, I misspelled apoc. That is a fail. There we go, nice and quick. So I'm just going to grab a copy of that again so that we know we cleaned up the names. So if we go back to our previous query where we were doing the distances, so we can do this, and I can get rid of all the clean stuff now. Right, actually, so we know what's going to happen. So we've done the clean, so we match those back, and we've gotten rid of all of these that were a complete and utter match. So let's have a look at metaphone now, because I'm quite curious. Right, so we've got double metaphone, so we don't need to do any cleaning, so I'm just going to cheat and I'm just going to add name because that's what we're working on, and let's see what happens when we run this. Same idea here, so calling metaphone, it's going to turn the names into like an equivalent set of characters, and then we're going to bring back what we think matches. So let's, oh, we're not doing a count, we want to return, we want to see all of this good stuff. So let's do v1.name, v2.name, and we want to return val 0 and val. Do we need to, no, we don't need to return those. We know they're going to be funny. We know what that's going to look like. So let's just do that. Let's see what comes back. Blend and plant. Oh my goodness, that is so funny. So we're probably going to have to do a little bit of things around this to try and sort it out. But oh wow, so it's saying there's 227. So we're going to have to mix a number of things to make this a bit more sensible. But this is interesting here, like the Mavrud and Mavrudi. I bet you they're the same. This one's probably like the Hungarian name, and this is going to probably be the Italian one. So that's really interesting. Okay, so this is very interesting. So we're probably not going to put all of our eggs in a basket around the metaphor. So we're probably going to have to compare the metaphone with something else to give us confidence that they are the same. But what I think we can do, and I think it's acceptable, is why don't we, so I'm just going to quickly rewrite this slightly because we don't need to do all of this cleaning and stuff because we've already done it now with the variety name. So I'm just going to quickly put in v1.name, we can get rid of this, and v2.name, and let's do where Similarity is greater than 8. So 8 was interesting because we had ones that were a little bit funny. So let's just do 8. Let's remind ourselves what that looked like. Because we've done all the cleaning now and the accents and whatever else. So it's basically the only one that we were a bit funny about was this one. And I'm kind of tempted to go, you know what, let it ride. So let's say, oh, let's be generous. Greater than or equal to 0.8. Just squeeze in a few more records. Let's see what those ones look like. So, oh, oops a daisy. Follerola. I'm feeling Vital. Let's go crazy. Let's do the same thing where we're going to say that these are all the same. So we're going to do the same trick that we did. So remember with the trick we did when we compared the words that were the same but they had like accents different, and we did that approach. So we're going to do exactly the same thing now with these nodes. So what we're going to do is we're going to do that trick where we are going to put a new relationship between the variety and variety name, v1 variety name, and then we're going to detach and delete all of v2 variety names. So like that we're going to get rid of another 50 records. And our threshold here is 0.8. So we're going to do the same trick as we did last time. So I'm just going to copy the back end of that query because it works so beautifully. Why reinvent the wheel? So do you remember, so we've got this bit, so with v2, v1, so what we can do, so we need to keep this stuff because that's our rule. So same idea here again, so we're saying where we need to do the variety, so let's just quickly extend that. Is component of var variety. So same idea. So what we're going to do is we're going to create a relationship between v1 and that variety, and then we're going to detach all of those relationships against v2 and then delete v2. So that's what's going on there. And our threshold that we're doing it is saying Levenstein similarity of 0.8 or higher. So I'm just going to grab a copy of that so that we know what we did, and let's run that. Okay. And we can't remember, did we have Shiraz in here? Syrah, I don't think Shiraz made it into here, so I might be a bit cheeky and manually do that. Oh, we don't need to, but let's do this. So we're going to do something a bit fun. I'm going to run a query, so let me just put a copy down of what we did here. And now that we've done that, so let's now remind ourselves how many variety names we've got. So let's do variety names. Remember we had about, when we started this, we had like 560, something like that, didn't we? So where are we at the moment? We are 511. I think we had about 580 or something. So we've cleaned out, you know, we've got a few of those. But the really fun thing now is if we want to say, well, okay, we've got our variety names, so our components, our variety component names, and now we've got variety. So let's do a count of how many varieties we have against variety name. So for example, if you think about, if we've got a variety name of Cabernet, then the variety it's going to have is Cabernet, Cabernet Sauvignon, Cabernet Sauvignon Shiraz, and so that kind of thing. So let's do that and let's see what comes back. So let's do match V and variety name is component of variety, and we're going to say with VN collect V as variety. I always set myself up for spelling this incorrectly. Right. I assume that's correct. I'm going to put it var. You know what I mean. And we are going to return bn.name. We are going to return size bar as s, order by s descending. So we're going to go from the highest number to the lowest number. So look at that Cabernet. So you've got, so that variety name, that tokenized name of Cabernet, there's 46 different varieties that map back to Cabernet. So if I grab a copy of this, so again, just keeping track of what we've been doing so I can write that up later on the blog post, and I'm going to quickly stick in the address for that. So you've got it. So I've just put that in the chat. So you go then, this is where I write everything up that we cover. So you'll be able to do all of this code in your own time and re-explore it. So we've done this. So let's have a look at what we've got in here. So let's look at the collection as well. So let's do var. I'm going to quickly tweak this so that I can do var.name. So we can have a look at those names. So let's do var and then size. So now we're going to get a collection of all of the names that sit under Cabernet. So there you go, look at this, all of the Cabernets going on here. You can see all of the Sauvignons, Blanc, Chardonnay, Merlot, Blend. You get the idea. So this is really cool. So now you can start to get a feel of how we're connecting all of these things together. So if we now want to do how many wines have we got under Cabernet. So remember, that's a reminder of how many wines we've got. So those of you who are new, let's have a quick look. So if we do wine, so this is all of the wine bottles, that wines that we got. I think we've got something like 119,000. Something like that. Cool. So let's see how many of the wines have a component of Cabernet. So how many of those have got Cabernet grape in there? So what we can do, and we said that wine has variety, doesn't it? Has variety. Let's go back to our wine. This is going to be fun. And what we're going to do is, I'm not going to collect the name because that will be crazy. So what we're doing here is, if you remember how things are joined together, we have got wine. Wine has a variety, and variety name is a component of variety. So we're using variety as a path to connect wine to variety name. So what we're going to do is collect V, so we're collecting the wines, so not V, we want to collect the wines, and let's do it as wines. And we are going to return the size of wines. So I am really intrigued now to see what is the most popular wine grape we've got in those 119 odd thousand wines. Blend, okay, fine. Blend, red, Pinot. But there you go, Chardonnay, look at that. That's a huge number of Chardonnay there. So that's, what, 5% of, no, hang on, is that right around? That's 12, 1/12 of all the wines we've got. or a Chardonnay. Then here goes a Cabernet, little Bordeaux. Look at that. That is pretty cool actually. So you can start to get an idea of what's going on. So this is probably not so meaningful at the moment. However, when we use the components, the variety names, to try and clean up the varieties a little bit, then that's going to be really interesting. So, okay, I think we've covered a lot of ground there. I think that's been really fun, really interesting. So I'm going to leave it there for now. Let's just quickly bring up the data model so you can see how it's changed. So we've only added that one component today, but let's show that. So you can see now we've now got offer variety, we've now got variety name, and that's getting very interesting. So what have we discovered today? That designation at the moment doesn't really add much for us, so we're probably not going to use that. We've added variety name to variety, so what we can do is we can do a bit of cleanup on variety to bring those down by a few. And what we can do as well with variety name is maybe that might be useful for getting specific grapes, so we can find out things that people like. So maybe we can make a bit more tailored recommendations if people like blends and that kind of thing. So that was really, really cool. If you've got any questions, now is a golden time to get them in the Twitch channel. Otherwise, I'll give you a couple of minutes. Otherwise, I think we're going to call it a day. And I will be back next week. So I'll be back next Friday, same time again. And I think what I wanted to do is have a look at the wine description. So if you have a look now at the data model, we don't have wine description yet, so we've not imported it. But if you remember, that's the one that had things like, you know, notes of melon and apple, and it tastes like this and whatever else. So I'm curious if we can do something with that. So we're probably going to do something similar as what we've done with variety. So we're going to tokenize that and see if we can do something cool with that. So that's going to be next week. So I shall leave it with that. I hope you've enjoyed this session. I hope you have a fantastic day. If you want to be notified of when we're live again, so my colleagues Michael and Will and Adam are also doing regular streams on Twitch. Don't forget to follow us on the Twitch channel, or if you follow @Near4J on Twitter, we normally send out a message an hour before we're due to broadcast. So again, you get notified that we're on there. So take care and have a fantastic day.